Review number 3, problem number 24, trying to find the limit as x goes to 0 of this. So if I plug in 0, I get 0 over 0. So it's indeterminate. When in doubt, I suppose you could use L'Hopital's. So try in L'Hopital's. Derivative of the top is 3 times tangent of 2x squared times the derivative of the inside, which is secant squared 2x times 2 all over 3x squared. Alright, so I get, let's see, 0 on top and 0 on the bottom. So we'd have to do another derivative on top and derivative on the bottom. That doesn't look like much fun. Okay, so if you did not want to do L'Hopital's, you would get there eventually doing L'Hopital's. It's probably the first thing I would try. If you wanted an alternate route, not necessarily that much easier, but we could analytically figure this out. So the top and bottom are both being cubed, so I can think of this as tan of 2x over x, the quantity cubed. Which is cubed times 1 over x cubed. Alright, so what's the tangent of 2x cubed? Well, that's the same as sine over cosine, so it's the sine of 2x over the cosine of 2x cubed times 1 over x cubed. And if you remember, one technique is you always want to try to find sine x over x's. Because sine x over x is this scenario where the limit of sine x over x as x goes to 0 is 1. So we have a sine of 2x over x, the quantity cubed, so I could think of this as sine of 2x over x cubed, and I still have the 1 over cosine of 2x cubed. Well, sine of 2x over x is, it's 2, but if we didn't know that, sine of 2x is 2 sine x cosine x. Sine of x over x is 1, so this goes to 1. And 2 times the cosine is 0, so remember we're still descending at 0, is 1, so this ends up being 2. So we get 2 cubed times 1 over cosine of 0 is 1, so 1 cubed, so 1 cubed. So after all of that, 2 cubed times 1, so we end up getting 8. Pretty long problem.